All right, so 2.5 properties. Properties specifically of multiplication and division. And yeah, some of these, you're going to see that some of these are kind of familiar. So this one, I mean, the identity property is familiar. It's just now it's a different operation, right? So in Module 1, we talked about the identity property of addition. And that's just where you add 0 to anything, you get the same thing back. This time it's multiplication. And the identity property for multiplication is multiplying by 1. So like on the second part right here, that's like saying you got one group of something. That just means you have the same thing. Or if you have a certain number groups of 1, then you have the same thing back. So anything times 1 is itself. That's really what this property is saying. But it's also called phantom ones. A phantom one indicates that if you were to take the multiply by 1, you can, it's not that I got rid of it necessarily. It's still there. It's just that you can't see it, right? So that's why it's a phantom value. It's there, you just can't see it. In fact, that's kind of what makes phantom values kind of creepy, is that they're there, they're always watching, but you just can't see them. That's the creepiness of it all, but it's there. See that right there? So anything times 1 is itself. And again, just, you know, if you look at that as groups, then it hopefully kind of makes sense on that. So we're going to look at these 4 problems, and we're just kind of filling in blanks, if you will. But just going back to what we saw, anything times 1 is itself. So in this first example, where it's 8 times 1, well, then you'd get the 8 back. And that's the identity part of it, right? You took something and you multiplied it by the 1, and you got the identity of itself back. Identity is the identity. That's true. So that's one reason why they call it the identity property, I suppose. Next up, we got 54 times 1. Well, anything times 1 is itself. Now, this may not seem so unique, but this is true even for decimal values or fractions or large numbers or small numbers or negatives. Doesn't matter. Whenever you multiply by 1, you get the same thing back. So on problems like this one, where it's 11 times what is itself, well, that's the identity property. Just fill that in with a 1. Or this last example, right? What times 1 is 2? Well, that'd have to be itself. 2 times 1 is itself. 2. There's a different color on that. There we go. So the commutative property, again, we've seen the commutative property, okay? It's just, again, before it was with addition. Now it's with multiplication. But just like we saw with addition and its inverse property, or operation, the subtraction, commutative property will not work with division. It will work with multiplication though, right? So remember that the commutative property will change the order. It changes the order of the values being multiplied. So right here, and it would work for more than 2 values, by the way, but A times B, we switch the order to B times A. That's all. And yeah, if it had a third value over here, it doesn't matter how you mix it up. As long as it's mixed up, then you would say that you're using the commutative property. But it's true in both cases. You can move stuff around. Like this example, if you said you had 5 groups of 10, you'd have 50. Or if you had 10 groups of 5, you'd still have 50. This questions, I think, is a good example of it. If you have 5 $10 bills, how much money do you have? Well, 5 $10 bills, when we talk about money, some of you guys are like, I got that one down. I would know pretty quick. That's $50. That's good. That's true. It would be $50. Now, and yes, I don't know a lot of people that have 5 $10 bills, but in any case, if you had 10 $5 bills, it's the same value, right? 10 5s, boom, $50. What is that, Grant on those $50 bills? So you can exchange 10, Hamiltons for Grant, or 10 Lincolns for a Grant, I guess. But yes, again, it works for more than 2 values at a time. All right, which of these 4 demonstrates the commutative property? Well, it has to change the order, right? So right here, how we have 2, then 3, but then it changes to 3, then a 2, means that the order changed. That's the commutative property right there, right? Now, let's just look at these other 3 and analyze them real quick, okay? So 2 times 0 is 0, okay? I think we've seen that, or you could just say, well, 2 groups of nothing is nothing, and that would be true. We'll go over that here in a second. Right here, it's 2 times 3 times 6, and then 2 times 3 times 6. See how the order didn't change on this one? This property should look familiar, which we're going to go over in the next slide, but it didn't change the order, so it is not the commutative property. And then the last one here, the identity property of multiplication. Anything times 1 is itself. 2 times 1 is itself. All right, the associative property of multiplication. You can multiply 2 values where you feel is most convenient. That's true. So if you looked at just a regular multiplication problem, got 3 factors. If you wanted to, you could multiply B and C first if you want. But if you wanted to multiply the A and B first, you could. And that's really what parentheses tell us to do, which we'll get into more later on. Some of you know that's order of operations stuff. But parentheses tell us that we have to do that first, no matter what. What this also means is that if you're dealing strictly with multiplication like this one, like if you were presented with a problem like this, and you wanted to do multiply the first two factors, you could. All right, so you can switch the order in which things are multiplied if you would like. But again, that's switching order, which really almost makes the associative property commutative, or at least it should show some relationship between the two. And yes, once again, there's no division property for associative. Let me say that a little better. There is no associative property for division. That's better. All right, so looking at these, we've got 4 options. Which one demonstrates the associative property? Let's go through each. So this one, 8 times 6, and then 6 times 8, which means that this one changes the order. The associative property will not change the order. It will not change order, usually. So this one, it can't be this one. That's the commutative property, though, just in case you were wondering. And then next up, we got 8 times 0 is 0. Of course, if you have any number of nothing, you'd get nothing back. That's not what this is. We know the associative property should include parentheses. This one didn't have any. So this next one, yeah, now we got parentheses. 8 times 4 times 9 equals 8 times 4 times 9. Well, we see that it's 8, 4, 9, 8, 4, 9. The order didn't change, but the location of the parentheses does. That is the associative property right there. And yeah, finally, 2 times 1. This is just the identity property of multiplication. So it's not that one. It's this one. So hopefully just that we've seen the commutative property and the associative property before with addition. Hopefully seeing it with multiplication really is not, doesn't make that too complicated for us. Now, multiplication property of 0, well, we did kind of go over this in the other slide, but this is like saying you got some number of nothing, right? Any groups of nothing still results in nothing. Or if you have no groups of something, you still have nothing. Okay, that's what both of these are stating to us. So hopefully this one ends up being just like instinct. If we ever see anything multiplied by 0, we should know that the product is just 0. Anything, oh, there we go. Anything multiplied by 0 is 0. The result or product is always going to be 0. Because it means you either have 0 groups of something, or you can have any number of groups of nothing and still have nothing left. So yeah, we got these problems. Again, this would read, you got 25 groups of nothing. Yeah, you still got nothing. Maybe that's kind of more sad than it needs to be. And yeah, even if we see fractions like this, right? 6/5 of nothing, there's still nothing, you guys. Or like this one, if you have no groups of 6.6, it indicates that you would have nothing. All right, you have to have some of the groups of something in order to have something. But if you have no groups of something, it's the same as having nothing. Now, again, it would be nice if these eventually just become instinct. You're like, oh, I see times 0, boom, the product is 0. Or like these other two as well. All right, 0 divided by anything. When we say 0 divided by anything, we're saying that the 0 is the dividend. That's crucial here. Because in the next property, we're going to see the 0, but it's not the dividend, it's going to be the divisor. But in this case, it is. And yeah, just because, there's math people out there that would get really mad at me if I didn't qualify this statement. There's only one scenario where this wouldn't be true, at least for now. We shouldn't see that, but 0 divided by anything should just be 0 for now, okay? Well, hopefully the fact family kind of makes sense on this one. Remember in the fact families that whatever the dividend is, that would be the product. So this kind of goes back to the last property we saw, multiplying by 0. The fact family on this would show you'd have 0 equals a times 0. And yeah, we already know that anything times 0 is 0. So the resulting division fact, 0 divided by anything, yeah, it's still 0. Okay, or how many times does 0 go into anything? That's still 0. And yeah, it shouldn't matter if you see this as a fraction division problem. Again, as long as you see 0 in the top here, or in the, top, the result is always going to be 0. No, there we go. We see 0 in the top of this fraction. So I don't really care right now what that bottom number is. The quotient here is 0. All right, well, what if it asks us to divide by 0? Well, then you're going to use D and E in the homework. Then, yeah, it should tell you to type in D and E. And I believe that it doesn't have to be capitalized. I'm capitalizing it here just to prove a point. But D and E stands for does not exist. D and E, okay? So anything divided by 0 is undefined. And what this means is, mathematically speaking, we can't actually quantify this value. Some people would say that it's infinity, and that'd be fine, because infinity is always changing. It's actually getting bigger as we speak. But it's undefined. That's what we're going to say. Or it just doesn't exist for now, okay? And again, we can look back to the fact family on this one. The dividend is the product of the multiplication. So you'd say 0 times something is a. Well, we already know that anything times 0 is 0. It should be 0 right here. So, well, there's not actually a value that we can put right here. It's garbage. So it doesn't exist for now. That's what this is saying. That when you see 0 is as the divisor, it's a does not exist scenario. So these two problems, they're saying the same thing. And we see right here, 0 is the bottom number. That's the divisor. And we shouldn't see 0 as the divisor. So here where we see 0 as the divisor, it's just a D and E case. Or right here, the 0 here is still in the divisor place. So still a D and E scenario. All right, fact families, we've already used some of them. Just remember that whatever your product is the dividend, or whatever you see in the dividend for your division problems. That is your product if you change it to multiplication. But your dividend is always the first number in the division part of this. And then you can switch out the two factors, though. Okay, and that's crucial to understand as well. Because sometimes with these fact families, we just change the division problem to its other fact family division problem as well. Yeah, and that's shown in these two examples also. So rewrite the division problems as multiplication problems in symbolic form, and then evaluate. Use a question mark as the missing factor, and we'll use the asterisk for multiplication. So rewrite this division problem as a multiplication problem. And yes, there's two ways to write this multiplication problem, all right? Now we know 45 here is the dividend. Okay, so it has to be the product. Yep, it has to be the product. So I'm going to take two values, multiply them, and it has to equal this product of 45. Well, what two values are there? There's only the 5 and the question mark. So if you wanted to, you could write it as 5 times question mark. Again, you'll use the asterisk in the homework. That's a bad asterisk, but whatever. If you switch it, that's fine too. You'd say you could take the asterisk and multiply it by 5, which equals 45, and that's good too. So either one of these would work. Now, I'll tell you this right now, on the homework, when you write this equation out, it does not want the 45 in the front. It does not want it there, okay? So do not write 45 equals this stuff or this stuff. You got to do the multiplication first. I don't know why that is. I assume it's just something with the coding in the homework program, but I'm just telling you right now, it will not accept the quotient, the dividend in the front. Now, we can solve this, though. In fact, we could have solved it from here, because 45 divided by 5. 5 is just one of the immediate factors we should know. Not factors, but multiples of 5. We should have that down, right? So 5 times what is 45? That's a 9. 9 times 5 is 45. If you use long division, you'll see you get nothing remaining there. So that means that the actual value of the question mark would be 9. So this would be one answer, and then either one of these would work, one or the other. All right, so finding these missing values. Well, if we're finding a missing value, changing these into either multiplication or the other division from the fact families should be very helpful. Like this first one. 5 equals something divided by 9, right? Now, there's something right here. That's the dividend right there, okay? Now, in the multiplication problem, this would be the product. And then the other two values just be multiplied. Well, we know the other two values. That's 5 and 9. So 5 times 9 is whatever this is, the product, which also is, in the fact family, the dividend. And we know 5 times 9, again, you can use the finger thing. Remember, you'd put down the 5th finger. You see 4 on the left, 5 on the right. That makes 45. So 5 equals 45 divided by 9. All right, in this problem, we do have the dividend divided by some unknown value equals 7. Now, so usually, just based on what we've done, we'd say, well, let's try the other operation, right? So you'd say, all right, well, the other operation is multiplication, and then you'd have the two values. Well, the dividend has to be the product, and the other two values are the factors in this, which means one of them is still unknown, but we want to work with these directly, which means I actually need the other division problem, right? So this would be, well, 91 divided by, now instead of a blank value, I'll have the 7, and this equals the blank. So the blank that we're looking for is the same blank throughout in the fact family, right? So here, now that I know it's 91 divided by 7, I can use some long division for this. 91 divided by 7. That works. So 7 will go into 9 once. Let me try that again. 1, there we go. 1 times 7 is 7, so we used up 7 of those 9, which means we have 2 left over. Let's go and drop that 1 in the ones place value. And 7 goes into 21 evenly. It goes into it exactly 3 times. 3 times 7 is 21, and this shows that we have nothing remaining in this one. So that empty value there is going to be that 13 we just found. 13. 91 divided by 13 is 7. All right, 44 equals something divided by 4. Here we see, this is just one of the factors that we're looking for. So the product we do have, and we know the product is the dividend in the division fact of this family. So I'd say, well, 44 divided by one of the two factors. It doesn't matter which one, right? So I can actually take the factor that we know, which in this case is 4. And when we find this quotient, that would be this other factor, which we don't know. So this is directly 44 divided by 4. And yeah, we can set this up with long division. I know not everyone needs the long division on this one. In fact, 44 is one of the first 12 multiples of 4. So if you knew that right away, that's fine. But I'm going to show it with long division, okay? The orange 4 will go into the green 4 once. So 1 times 4 is 4. So we used up all 4 of those 10s. And so I need to drop the 4 in the ones place value. That's a 4, by the way. Sorry about the handwriting. And then 4 will go in that 4 once as well. 1 times 4 is 4. And we show now that we have nothing remaining in this. So what do we get? 11 on that. 44 divided by 4 is 11, which means the fact family would show that 44 equals 11 times 4, and it does. Yeah, that would be true.